Well, it's all administered here.
Right, okay.
Yeah, but it's. And we draw
Overseas,
ITS staff. Yeah, I was really sorry that the Berkeley group cut you guys out.
Yeah.
I didn't.
That. Hoping, maybe this next cycle.
Hey, welcome to today's ITS seminar. I'm very pleased to introduce today's guest speaker, Anurag Pandey, who is an associate professor in civil engineering at Cal Poly San Luis Obispo. Anurag does work in the areas of traffic safety and road user behavior, among other things, serves on the TRB Committee on Safety Data Analysis and Evaluation. One of the other very interesting and very important things he's done is that he is the editor of the 7th edition of the Traffic Engineering Handbook for the Institute of Transportation Engineers. So IT has come up in a couple of the seminars we've had this quarter when we were talking about the level of service as the performance metric that's so widely used in the transportation field and the need to be thinking about alternatives to that. So it's great to have somebody like Anurag working on this new handbook because, as I think you're going to talk about, they're taking a very different sort of approach. So this is just another example of the kind of change that's going on in the transportation field, and in particular, the move away from being so focused on cars and meeting the needs of cars to understanding the needs of all users and how do we integrate this all together. So without further ado, let's welcome Anurag.
So I'll just hold on to this. Thank you, Susan. Oh, it has to be. Yeah. Okay. I'll just hold it. Okay. Thank you very much, Susan. So this was for having me here, and it's my pleasure to be here. As I'm going to talk about, I do have a little bit of a connection with UC Davis that I'm going to mention in my next slide here. So we'll talk about this topic, of course, performance measures on two-way stop control intersections for bicyclists. So that's kind of our focus research topic. But I'll also give you a little bit of my personal background, some research background about me as well. So I did my undergrad back in India in 2002. I got a degree in civil engineering, and I was looking to apply for grad school. And I applied for a bunch of school here in the U.S., and the two people who took a chance, who were ready to take a chance on me, were in fact UC Davis grads. So I'm very thankful. Yeah. So I got a fellowship at Central Florida. That's where I ended up going, and then I also had a fellowship at South Florida with Dr. Ram Pendyala. Does anybody familiar with that name? Yeah. So I ended up going to Central Florida, and I very much wanted to work in transportation planning, and I use the term wanted pretty loosely here because I was just an undergrad student who had done some transportation planning project work and some travel surveys and things, and I thought that's kind of what I wanted to do for my grad work as well. I get to University of Central Florida. My advisor says, hey, I got this great safety project. It's a great idea. Why don't you want to work on that? So I said, okay, we'll get started with that, at least for the master's degree. So I ended up doing my master's in traffic safety, more of a kind of freeway crash data analysis. I enjoyed that work, and then kind of extending that topic for a PhD. So that's where I did my PhD as well in 2005. So I got very active in the area of traffic safety, crash data analysis. So became active, as was my advisor, with the Safety Data Analysis and Evaluation Committee, and ANB20. And I'm still active, and I've become a member there. That's kind of my predominant research area is traffic safety, looking at crash patterns. And you'll notice that I don't use the term accident. That's kind of a no-no in traffic safety community, because if you use the term accident, it's kind of like, hey, is it an act of God or something? But it's not, so you want to call it a crash. So I joined Cal Poly in fall of 2008. It's been 7 years, and I got tenure just this year. I started as an associate professor now, so that's kind of a big monkey off my back, I guess. I took on a new assignment, which is related to service learning. So my new assignment is at Cal Poly is about engaging the community in our classroom. So having some community-related project that we can use in our classroom, and not just civil engineering, because this is whole university-based. So if there are any community partners out there who might be interested in having Cal Poly students work on some class projects that can ultimately benefit the community, and we can I'm trying to figure out how we can make use of that knowledge that Cal Poly students can provide, and that can also benefit the communities to have a mutually beneficial relationship between local and, in fact, global community and as well as the university. So that's something that I've been doing since winter of last year. My research activities, moving on to that. So that was my professional background. One of my project that was funded by National Science Foundation, as Susan pointed out, I work a little bit in traffic safety and driver behavior. So this driver behavior project, it's about, so again, the idea kind of came from looking at crash patterns and trying to figure out how can we identify long-term crash patterns on a freeway, or any roadway for that matter. How do we do that is we use long-term crash data. I hope you can see the problem with that. The problem with that approach is that if you're using long-term crash data, you're allowing all those crashes to happen. You're allowing all those crashes to take place, and then you can say, okay, yeah, here's the problem spot. Okay? So this project was about trying to capture some driver behavior data and trying to see if you can take all that GPS data and find out locations where drivers are having trouble, and trying to figure out patterns where drivers are having trouble. And those trouble would be they have to brake very sharply, so they can have like a very high rate of deceleration, so high jerk rate, for example. So try to capture those locations and see if those locations actually correlate with higher long-term crash locations. Okay, so if that's the case, then we can say, okay, maybe we don't have to wait all these 5 years or 10 years of crashes to accumulate before we can say this is a problem location and do something about it. So that's kind of where we're facing some issues with regards to, because the Highway Safety Manual, which takes the approach from, taking the long-term crash data and developing those regression models and using that for that long-term safety prediction, we're trying to figure out how can we integrate this new knowledge into that. Okay, so we're still trying to figure that out. So this was a study funded by the National Science Foundation. And so this is some of the other stuff that I've been doing, especially related to these multimodal analysis, trying to move away from this automobile focus. Analysis of bicycle and pedestrian crash data using latent class analysis. So latent class analysis is a little bit of a in the weeds kind of a statistical technique, but the idea of that is that instead of kind of dividing your crashes by your own preconceived categories, for example, you might want to analyze daytime crashes versus nighttime crashes, or crashes that happen on intersection versus those that happen not at intersection. Kind of taking those ad hoc categories out of the mix and trying to let the data guide you of what those categories ought to be. And based on that, trying to figure out some patterns. So we had some success with this at TRB. We published some work with regards to this at TRB about trying to understand the bicycle and pedestrian crash patterns using the latent class analysis. And the other thing that Susan pointed out, the multimodal traffic analysis we were doing, we were editing the traffic engineering handbook, and ITE, finally, I would say that they realized that they need to move away from that automobile focus and try to incorporate all the other modes that we want to have on our roads. Not just from the perspective of a sustainable transportation, but also from the perspective of having more economic activities being generated in our city centers. Okay? But then transportation and economic activities are very closely related. Then how do we make sure that all of our modes can be accommodated and we can have slower speeds on the city streets and maybe possibly higher speeds on the freeways? And how do we have a system that kind of exists together like that? So before this approach, I wouldn't say that ITE didn't have anything on bicycles or anything on pedestrians. They always had addressed these modes, but what they had done before is that they had taken a more of a layered approach. So the layered approach, I would call it, so they will analyze a road for automobile level of service, okay? And then they'll say, okay, now I'm going to add a bike lane and see what happens. And then, okay, where should the pedestrian crossing be so that it minimizes the impact on the automobile traffic? So they were taking, their previous versions of the handbooks, they would have a chapter on automobile, a chapter on traffic signal, a chapter on bicycles, a chapter on pedestrians, and that's the approach that they want to move away from. So they basically reorganized their whole content, and I would say we reorganized their whole content by inviting authors to write chapter not just on these fundamentals of traffic engineering, the idea of speed flow relationships and flow density relationship. We did have those, but in addition to that, we wrote chapters on city streets, for example. So there was no chapter separate on traffic signal and no chapter on city street or segment flow traffic. We said, okay, we are going to analyze city street as they exist in reality. And then we try to address all the modes and all the things that go together in the same way. So that edition should be coming out at some point this year. It should be going to press within the next couple of months. So we are very excited about that. To be honest with you, we are a little bit nervous about that too, because we don't know how the practitioners, which are the primary audience for that, is going to respond to it. So we've been kind of trying to solicit their feedback. And let me put it this way. Some of the feedback scares me a little bit, but some of the people are more open to it, and they are at least keeping an open mind to the book as it comes out. And of course, we had a very extensive review process. So beyond our editorship, there were, every chapter has 3 or 4 reviewers who are practitioners. And some of the comments that we got were kind of sobering. And I don't want to criticize all the comments, but because some of them really did help improve our chapters. But it was kind of a good process for me to go through. And then I did end up writing 2 chapters for the handbook as well. So that was kind of a good experience as well. And then one last thing I will talk about that I do is kind of get into this issue of outreaching to the high school students. We've known for a long time that transportation engineering has this issue of, and a lot of the different fields have this issue, is that a lot of our practicing professionals who are from previous generation, baby boomers, they're kind of getting close to retirement, and we're expecting the shortfall. That is already starting to happen, by the way, in our workforce. So the question is, how do we attract good students to the field of transportation engineering and transportation planning, for that matter? So I'm involved in a little bit of a K-12 outreach, little projects here and there. And what we are trying to do, the main thirst of those projects, is kind of exploit the idea of near-peer mentoring. Near-peer mentoring would be, you could have near peers in terms of age, because you could have some of your friends who are 2 or 3 years apart from you, who are pursuing transportation. Maybe they just had an internship. They go out in the field and or go out in the high schools and talk to the high school students and tell them, hey, the statistics lessons that you're learning now, how they are actually applied in the transportation industry. So kind of maybe keeps the students excited, the high school students excited in the statistics, that, hey, this really has some practical usage later on. And at the same time, it kind of engages them about this field of transportation, which not a lot of people have heard about, And the irony of it all is that everybody has contextual exposure to transportation. everybody either rides a bike here in Davis or is a pedestrian. Because I always, in any other audience, I'll just say everybody drives, but I didn't want to come out and say it here. So everybody's a user of the transportation system. So and that's actually a bad thing for transportation engineers sometimes, because they have to answer these phone calls where the person on the other side thinks they are an expert because they drive or they ride a bike or whatever. And in some extent they are. So one of my questions that I'm trying to explore is, how do we take that contextual exposure and use that for cognitive enhancement of transportation learning? Okay, so how do we do that? So that's kind of some of the other things that I'm trying to deal with. There is no paper out there that I've published on that area, but I'm still kind of trying to figure out how do we address that issue. So now I'm going to get to the current project. So the current project that I'm going to talk a little bit more in detail about today, so this is about trying to assess the operational performance of two-way stop control intersection. And if you read some of the European literature, they call it sometimes priority intersections, where one movement has priority while the other movement has no priority and they have to stop. So it's the two-way stop control intersection. And at those intersection approaches, what do bicyclists look for? What factors make a good intersection for a bicyclist? Now, ideally or theoretically, for this type of an issue, if you want to find out, okay, what's a good intersection for a bicyclist or any mode for that matter, where do you go for that? You go to the highway capacity manual. You're supposed to go to the highway capacity manual, figure out these performance measures, and learn, okay, yes, this is a good intersection because it has a higher level of service, or this is a good segment of the highway because it has a higher level of service. So how do you do that for two-way stop control intersections? So that's kind of the motivation for this, is that the highway capacity manual does not actually have any performance measures. So they have performance measures for bicyclists on signalized intersections, on arterial segments, but they don't have anything for the two-way stop control intersections. Now there's a kind of an interesting story about this, that, how do we actually zeroed in on this? Like, how did I actually learn about, because, bicyclists and these alternative modes were not my primary research area back in 2010 when the HCM came out, and I hadn't looked at it carefully enough to know that this gap exists. So one of my students actually came to me, and he had just gotten admitted to the master's program, and he said, I'm really interested in working with bicyclists. My first thought was, hey, you should have gone to UC Davis, but not really. But he comes to me and he talks about, I'm really interested in learning something more about, how bicyclists interact with traffic. And I hand him my fresh copy of this highway capacity manual. I think this was early 2011 or late 2011, maybe. Yeah. So I gave my fresh copy of highway capacity manual to him. I said, hey, knock yourself out. Find me a gap in this. And then whatever gap you come up with, we'll see if we can address that gap. And we can do some research on that. So that was kind of how this whole project. So this was more of a student-driven process. And this is something that, he kind of found this. And he found actually this quote here, that HCM does not have any methodology specific to two-way stop control intersections. And the thing is that two-way stop control intersections are, in fact, the most numerous type of traffic control that you're likely to encounter on the road if you're a bicyclist or any other mode, by the way. So we said, okay, we'll try to address this gap. And then this presentation is about how we actually did that. So the objective is to address the gap in the bicycle level of service performance measures. And we try to collect some data on two-way stop control intersections. And we went out and collected data for 41 two-way stop control intersections and 2 signalized intersections as well. And I'll tell you why we did that. In 5 different counties in California, and they were video recorded. So we video recorded those intersections from a bicyclist perspective. And the question is, so there were a couple of options as to how you're actually going to gather this data. Do you want to actually go out in the field and gather the data from bicyclists who are passing by and hand them a survey and have them come back and give you back the survey? Or do you want to actually just video collect the data and then have surveyors or the survey participants respond to the research or the questions that you have about the intersections, about how they felt about the approach and so forth? So we ended up using the video collection approach, and the reason for that is that, the NCHRP report that actually did the analysis, similar analysis for signalized intersection, they kind of dealt with this bias of if you hand out the survey to the respondents who are actually going through that intersection, they might be a biased sample in the sense that they probably already like that intersection. That's why they're going through it. Because the bicyclist, as a lot of you might be aware, that bicyclists will change their route if they don't like. So you're less likely to encounter a person who is likely to rate that intersection approach or in a negative way. You're less likely to encounter them actually at that intersection. Right? So that was the kind of idea why, and this was not our original thought. This is something that we learned from the literature, and it doesn't. I'm not saying that the video approach is perfect, and we're going to talk about some of the limitations of this study as well. And we'll try to drill some holes in that as well. So, but we ended up doing the video recording because this was more of an acceptable practice from the NCHRP research that went into actually the highway capacity manual. So this is the video data collection equipment. So this on the left here or on the right here is how the highway capacity manual, the NCHRP folks collected their data. So they basically put a video camera on their bicycle and then have them just pass through intersections, record the intersection, and just have the survey respondents kind of rate that approach. Now you can probably think about what the problems with that is, right? Probably not going to capture the pavement quality, may not be able to capture the effect of grade, and we didn't know if it is in fact able to capture or not. We just think that might be the case. But even though on balance we thought having a biased sample versus not being able to capture or potentially not being able to capture all these parameters, we still thought the video approach might be better. So, because this project wasn't actually externally funded, and we were funding it internally, so we kind of came up with our own low cost. So on the right here, you'll see that little bike that we created, and this was more of a traditional tandem bike, and our student kind of put a very steady GoPro camera on it. And those GoPro cameras, they are really nice. I mean, they can, I'm sure you've seen the videos on YouTube, so they can capture people while they're surfing and whatnot, all sorts of, more moving activities where there's a lot more movement than even riding a bicycle. So we were pretty satisfied with the performance of the video cameras as they recorded the intersection from a bicyclist perspective. Yeah? So we try to, so this is our video equipment. So this is what the survey data collection is. So once we collected all the video data, we kind of created some YouTube videos, and those YouTube videos, we showed them to participants, and we send out the link, and we reached out to some bicycle clubs, some community neighborhood associations, and these kind of places, and asked them to rate the intersection, how they feel about a particular approach. And our survey instrument, again, we didn't actually use the survey instrument. We didn't design the whole survey instrument from scratch. We took what was there in the NCHRP report, and that survey instrument were designed for signalized intersections. So we kind of just modified almost the same intersection or the same survey instrument and took that and redesigned it a little bit for the two-way stop control intersection, and just used that survey instrument. And that survey instrument you can find online in the NCHRP report, and our survey instrument is available online as well. Now, for the NCHRP report, what they did was they actually invited the participants in their center and then have them filled out. And their geographical location obviously was much more detailed. So they surveyed urban areas, 9 different urban areas throughout the country. I think they were in Chicago and these major metropolitan areas they were trying to capture. Of course, our project scales was, of course, much more limited, but we just wanted to see what factors are affecting, because this research is, of course, not as thorough as would go into the highway capacity manual, but we just wanted to learn about what factors are affecting these service performance at the signalized intersection, and maybe develop some quantifiable measures. So we actually handed out the surveys, have them surveyors filled out the survey online. And there are some concerns with that, and so we are relying on the information that they provide about their characteristics. So on the gender information, so we basically got all the surveys back, And we made sure that we had at least 40 respondents for each approach that we gathered the video data for. So at least 40 respondents. And those 40 respondents, we made sure that our sample looked like the NCHRP sample in terms of males and females, in terms of the age breakdown, and all of those things. So we try to make sure that the intersection sample that we are using is similar to the NCHRP sample. And so NCHRP sample was kind of biased in a way, but in the sense that they had more respondents that were owners of single-family residential units, and they likely had less experience with bicyclists. But because we went out to the bicycle clubs, we found that in our survey we found that was less of a concern actually. So in fact, even though we tried to in the gender and age, we tried to replicate the samples that the NCHRP research used for signalized intersection. In our research, we found that our sample was almost exactly like the NCHRP samples in terms of age and gender, but even a little bit better in terms of the concern they had identified about having more single-family owners than they would have liked, and so forth. So there was some concern about relying on people's information, but we thought for this purpose of this research, we could probably live with that. So as I mentioned earlier, that even though the focus of the project was trying to gather the data on information on the two-way stop control intersections, we did analyze some or two signalized intersection as well. And those signalized intersection basically provided us with 8 different approaches. They were all 4-legged approaches. So we had data on 8 similar approaches that we had. And what we did was we computed the average participant scores from the video responses that are the survey responses that we got after people watched those videos. And we took our survey responses and kind of matched them up with what NCHRP model would have provided for us from those approaches. And fortunately, we didn't see any significant difference between what we were seeing from our respondents versus what the calculation from the HCM would have looked like for these signalized intersection approaches. So that was kind of a good sign for us in terms of at least, and again, this was only done for 8 different approaches. So they probably would have been better if we had collected more data. And I'm going to try to, I know I'm kind of poking a lot of holes in our research, and I'm going to try to summarize all of those things at the end so we can talk about that and how we can address those issues. But again, we didn't observe any significant differences between what the approach score would have been from the HCM analysis versus what we were getting on average from our respondents. So that was kind of a good sign for us in terms of moving forward, in terms of how our videos looked and how our videos looked, and also if we got the survey mix kind of in good shape, or the respondent mix. So the issues that are unique to two-way stop control intersection. So I'm going to try to talk about what was our contribution here a little bit, is that if you look at the signalized intersection level of service methodology and in the HCM, this is what the equation looks like. So I have the score can be obtained by this empirical equation 4.13 FW plus FV. FW are the characteristics related to the intersection width, the crossing width that the bicyclist is passing, and those kind of things, and some other intersection characteristics that is represented through FW. And FW has its own big formula in the HCM that you could refer to if you're interested. You can go back and look at the HCM. And FV is about volume-related factors, okay, traffic volumes, and how much is the conflicting volume on the conflicting approach, and those kind of things. So these two factors, but they are used for the same approach. So any approach on any signalized intersection, this is the formula you apply. And of course, these FW and FV will change depending upon what approach you are. But they do have so FW and FV will change, but they have the same equation. The overall structure of the equation is the same, regardless of whichever approach are you on a signalized intersection. Okay? Now, question to us was should we take the same approach for two-way stop control intersection? We thought not, because we shouldn't take that approach, because the stop control approach is so different from the uncontrolled approach, that we should probably have a model. We should probably have a model that captures the stop control approach, and then we should have a model for the uncontrolled approach. So we should have probably two different models that represent the level of service or performance measure on those approaches. So we should have two different equations rather than the same equation. So that's why we ended up estimating separate models for major street approaches and minor street approaches. Now, so how did we do the analysis? We basically averaged out the survey respondents and how they were rating a particular approach. We asked them to rate them 0 for the worst and 5 for the best, and kind of average out what 40 respondents told us about that approach. And we noticed that the standard deviation wasn't that high between respondents. So that was another good sign. So it was not like we had like very few that were like rated 0 by one particular person and 5 by the other. So that probably happened because maybe that bicyclist or that user was probably familiar with that intersection approach, or they picked up on something from that video that kind of bumped them. But mostly, what we saw was that the standard deviation between the survey respondents wasn't that high. So what we did was we took the average and analyzed that average as a linear regression model with all the intersection characteristics that we had for our approach. So what we did was we had 41 intersections, two-way stop control intersections. We left 5 of them out from our sample, and we used the data from 36 intersections. So that gave us about 72 major street approaches and 72 minor street approaches. So we had basically 72 data points to analyze our model. And we regressed those average participant scores with a bunch of different variables, that we observed. And we kind of recorded these intersections during the same time that we wanted to analyze the data. So for example, if we had the traffic volume for the peak hour that we had available, that we had collected or had available, we try to capture the intersection at the same time as well. So we try to do that. So the regression model, so there was some modeling choices here, but what we found in the literature is that they mentioned that you could use the ordered probit or ordered logit model here, or you could go with the simple linear regression. The past research had not shown any significant difference between how the models would perform regardless. So we did find that we could use the linear regression approach and would be okay based on the findings from the past research. Yes? So what was the question? Right. But how comfortable are you? So we told them specifically how do you like this approach, and if you think you would feel unsafe about passing through this intersection, you may take that into consideration in rating an intersection lower. So the question that we phrased, I cannot remember off the top of my head the exact phrasing, but the question, the way we phrased it, we kind of modeled it based on the NCHRP report and tried to use the same approach. And because we also wanted to do some comparisons as to what that model looks at and what our model looks like. So we try to model it the same way. Sort of a safety. Not necessarily. We did point out safety focus, but also an operational focus. And what the interesting thing is that even though we did point that out for the safety focus in our question there, that they may take that into consideration, what we found is that there might be some conflict between, and I'm going to talk about that, a conflict between what the safety literature tells you about what's a safe intersection approach for bicyclists versus what these ratings came out to be. So maybe they end up considering more operational focus. It's a research question that remains to be answered there. So I'm going to point out what factors. So this is just a list of factors that we thought that came out significant in the model, and these are the factors that kind of affected the intersection perception negatively. Okay, so these factors, if they were present, they rated the respondents rated the intersection approach negatively, or a lower score, provided a lower score. So here you look at some of these. And this gives you kind of this, I point out here that, this is what tells you how little I knew about this issue of bicyclist and bicyclist movement and intersection when I was actually conducting this research. My student came back with a data point about like parking on the bike lane, whether that's allowed or not. It's like, huh? You can park on the bicycle lane? And apparently you can. I don't know how many of you knew about this. Maybe everybody? Parking is actually allowed. So if you look at the page 43, so I went to actually the DMV handbook and looked it up, and sure enough, they say you can park in the bike lane unless there is a no parking sign. Unless there is a specific prohibition on parking, you can park in the bicycle lane. So there you go. So if the parking on the bicycle lane is, and bicyclists apparently know this, or at least the people who, or at least we were able to capture that impact. If they didn't see a no parking sign while they were doing the video, so that was basically a clue that the bicycle was. So if there was not a no parking sign, the approach actually had a negative score or a lower score. So that was a significant negative coefficient there. And then we also saw if the median barrier is present near intersection, then that was also a negative for the bicyclist on the minor street approach. So this is approaching the stop sign when the bicyclists are approaching the stop sign. So this was kind of interesting. So all of these parameters were negatively rated, and they were significant. So I'm going to talk a little bit about the median barrier question in a little bit, because this kind of differs from the literature. Because the literature will typically tell you, because most of the literature was based on the bicyclist riding on a segment, and on a segment you want to have that median, that makes you feel safe. You don't have to face the oncoming traffic as a bicyclist. But if you're talking about intersection approach, that probably hinders your view, and that leads to the negative score. So again, another significant negative factor. And then if you look at the major street approach, what factors were kind of negative for the major street approach as well? So again, those same factors show up here as well. If the median barrier is present, then it's a negative even on the major street. Even on the major street, it's a negative. And then if the parking is allowed in the bike lane and zero otherwise, or if no bike lane is present. So if it's a shared lane or no bike lane is present, then also if there is so that again a negative factor. And then we saw something about the conflicting traffic volumes that we were picking up. So those approaches also came out to be negative. Now, again, we didn't explicitly, these were not captured explicitly in the video. I mean, they observed the traffic that was going during the same time that we had the traffic data for. But we didn't actually explicitly point out that to the respondents that this approach has that much traffic or anything like that. They were just watching the video from the same duration that we had the traffic data for. So some of these negative factors, look at some of the positive factors. And so let me address the question of median opening. And I don't know if you can see the picture very clearly. So what we observed was like almost all the medians will go right up the intersection. Okay? So maybe the answer might be that maybe when you're approaching a two-way stop control intersection on a highway, maybe the median, if you really want to make it bike friendly, maybe the median opening should begin a little bit further upstream of the intersection approach or intersection location. So maybe you want to open up your median before that to make it a little bit better for the bicyclist. But most of the medians that we observed, they went right up to the intersection like the one here. So this is the intersection is right there, and then the median kind of goes right up until that point. So let's look at now and I was just telling you that the perception on segments, it affects it positively, but if you talk about the intersections, the two-way stop control intersection, then it affects it negatively. So this is the minor street approach. Again, one thing that we were surprised that we picked up, and again, this might be a quirk of the sample or whatever it is, because we didn't actually disclose what the grade was on each approach. They probably inferred it from the video itself, like, okay, if they're going downhill or going uphill. So slope was a positive factor, and I think that probably was the reason is that, what we kind of inferred from that is that potential reason for that might be that if the bicyclist go, and this is minor street approach again, so I'm talking about some factors that affected the perception more positively on the minor street approach, the minor street approach. So slope was like if the grade was a higher grade, then bicyclists tend to like that a little bit better. then, and I don't know if we're really capturing something or this is a statistical quirk here. It's hard to ascertain the causality. But what we guessed was that might be the case here is that if you're really going downhill on the minor street, you hit that negative slope and like having to stop at the stop sign. Now, the question is like, it was brought to my attention and, how many bicyclists are actually stopping at the stop sign? So there's that question of enforcement and I'm sure there are much better bicyclists here than you'll encounter in even San Luis Obispo and other parts of the country. But anyway, so that was that question that came up. But anyway, so that's something that we inferred that could be a potential reason that if you're going downhill, you don't want to stop. So that's why you probably like more steep grade or at least upper grades or going upgrade or maybe flat. You definitely don't like the really steep negative grades here. So that could potentially be the reason. And then we also noticed that there were peak hour traffic volume. So that was kind of another thing that if in your direction, on the minor street approach, log sum of peak hour traffic volumes with the direction of approach, that came out to be a positive coefficient. That kind of surprised us a little bit. On your direction was positive, but maybe that probably meant that the riders on the other side were driving slowly, maybe more aware of the automobile traffic that was coming from the stop sign. And again, this is not something we can make a causal connection, and that is the case with any kind of statistical analysis, but that's something that might be going on. And then if you had shared lane markings, that was also a positive. If you had a shared, yes.
On the peak hour, if you're at a stop sign and there's a car next to you and the car goes, you go.
Yeah.
So
there is that factor as well. So yes, so having a car, more traffic with you or going in your direction probably helps the bicyclist out, and that probably led to, and they were probably picking up on that gap that some automobile provided. And again, we didn't give them the actual traffic volumes. We just collected the data at the same time, as I mentioned earlier. And if shared lane markings are present, zero otherwise, so this could be another interesting one, because this probably interacts with the traffic volume. So, but we didn't have enough sample size to look at all the interaction terms, and that's something that potentially could be looked at. Talk about the major street approach. On the major street approach, one thing that we noticed is that having more time. So this measure, I want to explain about this measure a little bit. This is a measure of this first one, the side distance divided by the major street speed limit. That's kind of telling you your time to collision point, like how far you are from the collision point when you see the approaching traffic. So if you're familiar with the side triangles that happen at these intersections, so this is kind of measuring how far you are when you actually notice the cross traffic. So on the major street, when you notice the cross traffic, how far actually you are. Yeah, we basically looked at the side distances. Like, we assumed that bicyclist eye height and motorist eye height are not going to be that different. So we basically assumed that the side distance is measured as based on the fact that when the cross traffic becomes available and or becomes visible, and from the same location as so it will be the same value for whether you're a motorist or a bicyclist at that point. So same value was used. And then this major street speed limit, again, it could be, so this is not from a bicyclist time to collision point. This is just a time to collision point, just trying to measure a sense that the bicyclist will get. And you could actually use, that'll just a proportional impact if you use the bicycle speed. Okay, so that's not the critical issue. The critical issue is like, how far, what's the distance perception or the time perception you have when you're going to see. So if you see the conflicting traffic sooner, if you see so that was a positive factor. And let me think what's going on here is that if you had a side distance, it's a positive coefficient here, and major streets. So if you have more time to that collision point, then that will be a good thing. So if you can see the cross traffic as a bicyclist, if you see the cross traffic sooner, then you can interact because you want to make sure that people are actually trying to stop, because sometimes you're making sure that the motorist that's approaching from the stop sign is able to see you, because this is the bicyclist on the major street approach. So more time you have, it's a better it's a better perception score. So they were able to capture that. And then there are other things like the bicycle signage. There are some factors that related to bus stop present. That came out to be a positive coefficient, and we just didn't have probably enough sample size out of the approaches that we had, the 72 approaches that we were modeling with. About 8 of them had the stop sign or the bus stop on the near side. So that might be an issue that you have a lower sample size. So there might be something going on related to the sample size here as well. Okay, so one thing that came up when we were discussing these results with one of the colleagues who's a practitioner, and person is very automobile oriented, but I think we got some good insight from that, is that when you looked at the model coefficients, we had the total volume on all approaches in our model, and then we had the volume that goes along with you on the minor street approach. So we had the total volume on all approaches, we had a coefficients for that, and then we had the volume that goes with you, the traffic volume that goes with the bicyclist on the minor street approach. So we had those two variables in our model, but we didn't specifically had the conflicting volume. But if you are familiar with how the level of service works in the context of highway capacity manual for automobiles, you'll notice that on two-way stop control intersection, it's all about how much conflict do you encounter when you're stopped at that stop sign. It makes sense, right? Excuse me. So he wanted to see whether your model is giving consistent results for the bicyclist as well in terms of the conflicting. So what he wanted to see was that, is your level of service or the performance measure going down as your conflict volume increases? And sure enough, that's what I'm trying to demonstrate here. If you increase your conflicting volume according to the model, if you put a larger and larger value for the conflicting volume for the same total traffic volume or same volume that's going with you, what you see is a consistent going down of the score. And that kind of makes sense that if you have more conflicting volume, you're going to have to wait longer, lead you to for a much worse perception of level of service there. So the city of Goleta intersection, so these were the 5 intersections that we had left out, that we didn't use for our model. Okay, so these, because we collected data on 41 intersections, we only used 36 intersections for analysis, so 72 approaches. So with this, we had 10 major street approaches and 10 minor street approaches that we had data for. And what we want to see is yes, intuitively it makes sense that you want to model the major street separate from the minor street. But just for the sake of it, we actually calculated a model that didn't actually differentiate between the approaches. So we had much larger sample size, we just doubled our sample size. So we had, instead of having 2 models that we developed with 72 observations each, we developed just one model with 144 different observations from those 36 intersections, and said, okay, we're going to treat every approach the same. We're going to calculate these variables and not differentiate between the major and the minor approaches, and try to develop a model and see if that model kind of is able to capture what the perception scores that we are getting. Okay? But what we found was that, if you look at the perception score that you got from the model and the perception score that you got from the respondents, actually, at these Goleta intersections that were not actually part of the modeling process and only used for validation, we noticed that there's no significant difference between, if you compare the major street model to the major street perception score for these 5 intersections. And same thing for the minor street approach model. But then, if you look at the combined model, that indeed didn't capture. So there was a difference of there is a statistically significant difference between the perception score that you'll get out of the model, of the combined model, and then the perception score that you'll get out of the perception score that you got from the respondents. So that just didn't capture them very well at all. So that kind of more of a quantitative evidence here that you must model the minor street and major street approaches separately than trying to model them together. So here are some conclusions. One thing that, what you can do with it sort of information. And of course, there is probably more questions that need to be answered about, increasing the sample size, maybe trying to have more diverse location. and that those issues are related because if you have more sample size, you can probably analyze more data or more locations or more diverse locations. But definitely one conclusion for sure is that you should definitely look at the stop sign approach, or stop control approach, and the non-stop control approaches separately. That definitely needs to happen. And then we kind of figured out, like, okay, maybe able to improve bicyclist perceptions by disallowing parking on bicycle lanes. Like all the time, you just put a sign there that no parking on bike lanes all the time. And then you have to enforce it too, because we noticed that some of the cases when we were collecting this data, and I was not doing it personally, but my student showed me a lot of pictures where there was a sign, parking is not allowed. There was still somebody parked there, and that was encountered like maybe 4 or 5 times that he was out in the field. So that was so you need to enforce that as well if you want to improve the bicyclist perception. And then you provide, if you cannot have a bicycle lane, then maybe you provide the shared lane markings. So that helps bicyclist perception. And you can infer more things from this model that you're kind of more sure about. You could where you had enough representative samples in different categories. Maybe you can be kind of more sure about those things, and you can take those lessons and implement that in the field. So the other question that came up, and that's kind of interesting to me, and it still needs to be looked at because, as I told you, my area this is not my primary area of research, or at least had not been before I kind of got into this research problem. I try to look for what's the safety kind of concern here. So I try to look for some safety issues, some literature on traffic safety at the two-way stop control intersection, specifically as they relate to bicyclists. Okay, and that I learned, but my student learned a lesson in literature review that time, is that he kept looking for it and two-way stop control intersections and safety and bicycles. He couldn't find anything. So we were stumped. I said there had to be something, right? There had to be some research somewhere. Somebody must be doing it. And and we just had a discussion about some unrelated topic a couple of days before that research, and somebody came up to me and we were discussing that how people use different terms in Europe than they used in the US, and then those terms and that discussion was about some topic else that I don't even remember anymore. But we just had that discussion, and my student was having this problem of he was not finding anything related to safety on two-way stop control intersections, specifically to the bicycle safety. He was finding a lot of literature to automobile safety or the overall crash patterns, but nothing specific to the bicyclist. And we said, okay, so these are called priority intersections in Europe. So we should probably look for that priority intersection, safety, bicyclist, and you'll probably find something more. And because Europe, especially Netherlands, a lot of this research has gone on, is that they are more, bike aware. The bicycle is kind of more of the norm there. So sure enough, we found at least some studies that looked at the bicycle safety on these type of intersections, and those are called the priority intersections. So if you're doing a literature search and you're not finding anything, that's one lesson that I learned. I mean, I kind of learned it 2 days before my student, but I taught him that lesson 2 days later. So we were talking about this unrelated issue, and we were able to use that. So anyway, so these two studies that I found, and there are not a lot of studies here there either, but the studies that I found was more bicycle motor vehicle crashes occur at well-marked bicycle crossings. And from our performance perspective, we are seeing bicyclists will rate them highly, but they might be leading to more crashes. So that interplay has to be looked at if you try to improve the bicyclist performance. And that kind of also goes to that, the contextual exposure question that I talked about. Everybody rides, and they have perceptions, and we use that perception. Thank you for those responses. We use those perceptions in this research. But those perceptions could be misleading in terms of safety here. So there's some evidence, and this research was not done in the US, so maybe we need to because maybe the US road users are looking for more directions than the European road users. So maybe the directions here would really be helpful. We don't know the answer to that question because there's just no research out there in the US. Or maybe somebody needs to look at it. More bicycle motor vehicle crashes occur at well-marked bicycle crossings. Maybe it won't be the case in US, or maybe it will be. We just don't know. But maybe this contradiction between what improves the perception of an intersection versus what really is safer for the bicyclist. Maybe these are two different questions. Maybe they are related questions. Maybe with regards to some parameters, they're related in the same way. Maybe in some other regards, they're contradictory from each other. So those things are kind of have to be looked at. And same thing, bicycle tracks at junction. And this is European literature, so I just kind of copied. And I would never use the term accident, by the way. But I'm just quoting a study, so I just use what they had there. But again, significant increase of bicycle crash numbers due to bicycle tracks at junction. So having the bicycle tracks, bicycle lanes at intersections that could really affect certain things. So those questions have to be looked at from a safety perspective as well. Now, some limitations here. Of course, wider range of data collection locations. I mean, we found in one of the models that bus stop is a really significant factor. But is it really, or is it just because we had certain intersections that would have been different anyway, and just a limited sample size is causing it? Increased number of surveyed intersections, especially the signalized ones. So maybe if you want to do more validation, we just did it for like 2 signalized intersections that just gave us 8 approaches. But maybe we need to kind of look at different types of signalized intersections and kind of try to validate our approach there. And again, effect of pavement and slope, is that really being captured? Or are we just seeing some statistical quirk here? Excuse me. So again, interaction between shadow markings, the shared arrows, bicycle lane and vehicular volumes. Maybe at higher vehicular volumes, the drivers would really like to have the bicycle lane rather than shadow markings. Or maybe at lower volumes, they prefer to have those some kind of marking than not. So these questions have to be looked at, like the interaction between these 3 variables, especially, just to take an example, needs to be investigated here as well. So if you want to read more about this research, this is the TRB paper 151389. You can find that, or if you want to send me an email, I can forward you that paper as well. So this is where you'll find a lot more details about this analysis. And here's my contact information if you guys have any future questions. And of course, I'll be happy to answer any questions that you guys might have right now. And again, please remind me that I need to repeat the questions for our online audience if I don't do that. Okay. Any questions?
Hypothesized factors that you thought might have been significant.
Okay, so I don't remember off the top of my head what we left out of the model there. Oh, yes. See, I don't remember. Okay, yeah. So the question is whether there were some factors that we thought would have been significant for the bicyclist perception that going into the analysis that we thought would be significant, but they didn't actually come out to be significant in our analysis. Now, I cannot remember anything off the top of my head, but definitely this median opening question, based on what we had in the literature, we thought this would have a positive sign, but it actually didn't have a negative sign. But definitely, if you send me an email, I could answer that question in more detail. I'll have to refer to my student thesis. But yeah, that's a good question that I don't know the answer at the top of my head. So I guess there were no big surprises in terms of inclusion in the model, because if there were any, I probably would note them here, or at least would remember it. But maybe there were, and I'm not just remembering them. So email me, I'll be happy to answer that question. You have another question? Yeah.
So I had a comment and a question. So Professor John Harvey and I, a group of pavement researchers here, actually looked at bicyclists and pavement, and there definitely is a relationship.
Yes. Yes.
And then I was also wondering, when you were talking about the Dutch studies at the end, were they looking at raw numbers of crashes, or were they looking at exposure?
No, they are looking at more sophisticated analysis of the intersection crashes. So they were not just looking at the raw number. So when I quote those findings, I'm just simply quoting the final essence of it. But yes, so there was much more detailed analysis to that. Yes, so those were studies that were kind of using. Okay, I probably should have repeated the question.
They'll get the gist of it.
Yeah. And by the time all the questions will be over. So the question is, the comment is that, yes, there is a significant relationship between the pavement quality and the bicyclist perception, and there might be even some unique natures of how pavements kind of affect the bicyclist perception in the way that they don't for the automobile driver or even the pedestrians. And then, so the question was, the European studies that I'm citing that affect the traffic safety, were they more rigorous safety analysis, or they were just looking at the raw numbers? And so they are indeed looking at rigorous statistical analysis of crash patterns, and based on that, they're saying that certain factors increase the crashes, or at least are associated with increased crashes on these two-way stop control intersections. So yes, that does include some rigorous analysis there.
So now that you've created this model,
it's so the question is, so what's the next step for this analysis? Is this model being made available to the public, to the cities? So the answer to that question is that because this research wasn't externally funded research, it wasn't actually so this is not going to some city or anything like that as of now. But of course, we have our TRB paper out there, and I've been talking to some folks. So yeah, we do want to make this available widely, but I think there are some statistical questions that probably need to be investigated in much more detail before this can be used by the cities. Certainly there are some ideas here. Certainly there are ideas that hopefully the next edition of the HCM will incorporate. They might even be doing this kind of a research to enhance the next version of the highway capacity manual whenever that's coming out. So that could probably have something in there, and they might already be working on it. I'm not aware of that because there is no published research on that out here. But I think one thing that needs to happen is that agencies need to be made aware of these contradictory findings that comes from the safety literature. You cannot just improve the perception, go about improving the perception. I think this question hasn't even been looked at for the bicyclist level of service at signalized intersections. So if you're improving a signalized intersection for bicyclists and you're using your LOS methods from the highway capacity manual, you probably should look at literature that looks at the signalized intersection and bicyclist-related safety factors as well. I think those questions. So I think if you cannot take anything else out of this research, I think you should definitely take this out of that, is that you have to be aware of the potential contradictory nature of what the safety evidence might be telling you about the bicyclist perception. You can improve the perception, but maybe you will be worsening the safety. So you have to be aware of that, even not just related to two-way stop control intersection, but all different types of intersection, even those approaches where you have well-established model in the highway capacity manual. I think that would be something that the cities ought to be doing. And we plan to do more outreach about this and see where that goes. But yeah, that's a good suggestion there. Yeah, so the question is the bicyclist or the intersections that we analyzed for two-way stop control intersections, did they have bicycle boxes or anything like that? So none of the intersection approaches that we encountered had bicyclist boxes. Some of them did have bicycle lanes, some of them had shared marking, some of them had other features, but no bicyclist boxes here on the two-way. I don't know if they're very common on two-way stop control intersections. So we were just kind of sampling the intersections, and we didn't encounter any. Even if we had, we probably would have excluded them from our analysis because there would have been so few. But yeah, so we did not actually had any kind of those kind of more sophisticated bicycle boxes type of stuff. But again, good research questions needs to be looked at in terms of how that helps the bicyclist performance. Might be more useful for signalized intersection approaches than the two-way stop control, because that's where they're more common. Because on those you have more traffic volume coming in on signalized intersections, and then you only have a limited amount of time to pass through. So you want to give the bicyclist a fair shot, so you want to have them pull up in the bicycle boxes. Yes, Kevin?
So when the participants in the study are reviewing how they feel about each approach, are they assuming that they're going through an intersection, or are they going through or making U-turns? They can see where it might make a difference where, oh, well, I can see straight through this intersection just fine.
Right.
There's something about the other side of the street.
Yes.
They can turn not very well.
Right. So the question is, as I understand, is that how were different movements from the same approach were differentiated? I mean, was there maybe making a left turn or maybe making a right turn might have been, how is that different from going through, for example? If those three things are, if those three different movements from the same approach are different, maybe one movement is much better, one movement is much worse. So how is that captured in the model? So basically what we did was when we created the video, we created the video in a way that we captured all three movements. So we basically had the video recording of the going through, turning left, and turning right. And before the respondents rated any approach, they watched the video that incorporated all three movements, and they were asked to rate, okay, on an average, how would you rate the three approaches? Now, it would have been much better to probably rate each movement separately. But again, then you end up with too much. When we were actually conceiving this research, we had high hopes of kind of taking this to the HCM level, highway capacity manual level. So we were in fact concerned about trying to capture the model that we wanted to make sure that it's easily applicable. So we thought okay, maybe it's a good idea to take the approach that the HCM takes and kind of rates those approaches kind of together, or rate those movements together on the same approach. So we took the same approach. And again, it will probably, if you want to analyze all three movements separately, you'll require even more additional sample size. So at least 3 times the sample size. So you'll need more intersections to be able to analyze them separately. Okay, so there is the question is about what's the difference between the major street analysis model, minor street analysis model, and and the combined model, and what accounts for that difference that we showed that there is no significant difference between if you look at the major and minor street model, but there is when you look at the combined model. So that actually relates to I don't think I made it clear what I was trying to say there. The idea here was that if you look at the signalized intersection level of service performance model for bicyclists in the HCM, it kind of treats each approach as the same. So any intersection, they get 4 data points. They get 4 data points. When you're trying to analyze, each intersection will give you 4 different data points on 4 different approaches of a 4-legged intersection, signalized intersection. The question is, could we do the same thing? On a 2-way stop control intersection, could you combine and develop same model that is applicable for the two uncontrolled approaches and the 2 controlled approaches? Intuitively, our answer was no, it's not a good idea. And what I was showing in that slide was that yes, even quantitatively, it's not a good idea because you double your sample size. Like now you have 150 from 36 intersection. Now you get 154 data points. But those 154 data points are actually not really 154 data points. Those are one bunch of 72 data points and one bunch of 72 data points. Now, if I start thinking about the lessons that I've learned from other research, they might not actually be 72 and 72. Maybe there is some latent classes in there. I don't know, but I don't want to get into all that as of now. Too complicated here. Yes. Yes, so in the survey, so the question is, whether we kept any record of the bicyclists that we encountered on these intersections when we were collecting the data. And the other question is, did we take into account how many of these respondents were actual bicyclists versus how many of them were not bicyclists? So yeah, we did have those information, and so we didn't encounter a significant number of bicyclists at any of these locations that we thought was should be noted in any of the analysis. We did not see any significant number of bicyclists at these locations because the data collection process, we did it during the peak hours, and the data collection probably took like maybe half an hour through an intersection, and within that period we didn't encounter any significant number of bicyclists that we needed to account for. Yeah, you weren't in Davis, yeah. That's so. Yeah, definitely. If we were in Davis, we'll probably encounter some bicyclists. I don't know how that will play though. Maybe if the video watchers noticed a lot of bicyclists on that intersection, I think that might bias the result in terms of maybe they'll make them more likely to say, yeah, that's a good intersection. A lot of bicyclists here. I don't know. Yeah, that's a good question. But yeah, so if you need to probably be at that location. But we did not encounter any significant number of bicyclists. And the other question was, so yeah, when we were collecting the data, did we take into account how many people were actual bicyclists? And yes, in the survey we did note that. And so we did not use whether they were using bicycles for commuting. We did not actually use that information, because we tried to make the survey consistent with the NCHRP research that went into the highway capacity manual. What we did was we note that, okay, how many of them use modes other than automobile, including, and then we broke it down by bicycle. So our population, sample population, as I said, was same in terms of age and gender, but it was, we had more bicyclists more sample representation for the folks who actually use the bicycle mode than the NCHRP sample. So they were slightly higher. So I think there was like about 60% of the respondents in the NCHRP they did not use the bicycle. For our sample, it was more like 32%, I'm thinking, is that they did not use the bicycle. 68% of them did. Yeah. And yeah. Right. So yes, absolutely. The bicyclist, if the bicyclists are rating something, how significant is the difference? And I think the NCHRP research did explore the question whether a common bicyclist rates an intersection approach highly or less highly. So they noticed some differences, but they didn't notice like a trend in the difference. I think that trend kind of got lost when they were analyzing the signalized intersection. So that the NCHRP result that it's obviously not in the HCM, but the NCHRP research that it actually went into the HCM, that they do explore this question a little bit. So you might want to refer to that.
Great to see some good science.
Thank you very much. Thanks.
How'd you get all that data collection done without funding?
We had some intern funding, and the student was very motivated.
Yeah.
So he just went out in the field. Yeah. I had some, my professional account money and some dean funded a little bit of it. Just kind of put together about.
Well, then the video approach, I mean, you couldn't take people out there.
Yeah.
Right. Yeah, but that online option is a great way to be able to get a big sample.
At least some sample. There's problems with that.
Fascinating.
Okay. Oh, you made it to 27. Okay.
27 is like if you're going to like burn out and not stay away, that's going to be pretty
Let's see. So I already looked, right? Oh, wait, filing fee. That's good. Okay. So here.
Nobody likes 77.
That's the point.
And so this means you're going to have a draft early in the course. Yeah.
How they
Very soon.
did that. So
That's
that was
At the beginning.
good.
right.
Carter's going to go
Yeah,
fast.
at least some parameters might not.
Hey, how are you doing?
I'm good. How are you?
Good.
I was wondering, are there any upper division TTC classes offered next quarter? There'd be similar to like, there was like that type one last year.
Yeah, no, we're not. Well, let's see. So Dan Sperling's doing his policy class,
Right.
but if you had him as an undergrad, I
Yeah,
would have
I
different.
had.
So we are doing Gil Tal's doing a spatial analysis class that TTP is supporting, but it's not necessarily dissertation specific. But you might look into that. That could be a lot of fun.
Do you know what number it is?
No, not
Okay, but it would be listed in like.
Yeah, you could check with Anne Marie
Okay.
Schaff or even